right. Yeah, today we're going to be working on initializing the structure of chip 8. So let's start, working towards that. So first of all, let me open up the repository. So we have the relevant references, so I can open those up. So technical reference 2 mainly, and the STO2 reference. I'll keep both those open. So yeah, let's go to the memory map, right? So let's do that actually. So right now, I'm gonna keep things simple. I'm gonna organize everything in one file. However, as you can imagine, I'm gonna start separating these out into their own header files, right? So yeah, let me just do that for now. In fact, actually, what I can do is yeah, we have source. Okay, yeah. As I mentioned, for now, just to reduce the complications and stuff like modifying the make file and all of that, I'm just gonna keep these simple. I'm gonna declare the struct over here. So, and keep in mind, we don't need to actually declare this as a struct. I've been kind of following some of the work and some of the stuff that John Blow and Casey have been talking about with kind of the OOP mindset, and I think that's kind of rubbed off on me as well. So I am a newer programmer, of course, but I think a struct makes sense in this case. I mean, I cannot declare the struct as well. I can just declare the memory map, the display, all of those things separately. It's just variables which exist independently of this structure. However, I think ultimate, well, I don't need the struct, but I mean, it doesn't hurt to have one. Makes things maybe a little bit more clear. So let's do struct chip8, right? And what we want to do is we want the memory map, which is 4096 bytes, right? So what we would want is an 8-bit, which I believe is uint8, right? So you want a uint8 mem map or mmap rather, right? And that's gonna be of size const short or unsigned short memory size equals 4096, right? So that will be 4096. Then we have the registers, which is the general purpose registers. So let's do that. Const unsigned. Actually, I can just do const uint8t, sure. Can do the same thing here. Actually, this will be uint16t, I believe. Yep. This would be uint8t, no, uint16t again, excuse me. uint16t screen height. And then again we have uint16t, rather 16t. I'm actually curious about, I was looking at some of these like fast 16. What does this mean? What is the difference between the fast and then the normal version? It's actually a question I'm going to jot down. Open my vault. Okay. uint 8t general purpose regs. I'll just do that. Sorry, just looking through the notes real quick. Excuse me. Questions. What's the difference between uint 8t Okay, cool. So yeah, I mean, we have our structure, which will be consist of the memory map. Then we have uint 8t. We just call this v since that's how we actually reference them. And then our general purpose registers, we have 16 of these, right? So general purpose. Why am I not able to reference this? Oh, right, we have v, we have mmap. What's the issue here? Mmap is never used. V. Okay, I don't know what that error message means. I'm thinking it's just because I'm not using it right now, but we'll see. Alright, then we have the sound and delay timers. So, and those will just be 16-bit, I believe. uint 16t sound timer, delay timer. Actually, I just realized I can just do this. Special 8-bit. Oh, never mind. These are 8-bit. So again, this will go over here. We have a 16-bit program counter, right? So it's PC, right? Stack pointer is 8-bit. However, our stack is stack depth is 16 as well, but it consists of 16-bit elements, right, which are addresses for the program counter, like addresses previously executing instruction address, right? So okay, sound delay timer, all right, and then we also have the opcode, which will also be 16-bit. Opcode looks good, yeah. So this is our structure, right? We have our memory map, we have our general purpose registers, we have a sound timer, delay timer, stack pointer, program counter, stack, and opcode, right? And we also have keyboard, that's a good point. So our keyboard will just be uint 8t. It doesn't even have to be 8-bit. And maybe there's a way we can fix that later, but that's something maybe to think about, which I'm also gonna note down. Because what I'm thinking is we have 16 characters. When a character is on, it has, you just have a one, kind of like a bool, right? Like a flag. Like a character is being pressed, we have that flag go off. If it's not pressed, it's zero, right? Or false, whatever. So perhaps it can be a 16-bit element bool. Let's see how much bool bytes. See. Yeah, it takes 1 byte. Okay, so it's the same as an 8 bits. Right. I think there's a question about this. It's a little I think it makes sense. I don't think things are stored as a bit. The following code will show you the size. All right, standard, okay, and declared is large enough to store the, as mentioned, the size cannot be smaller than one, but it would be legal. Okay, it's an interesting thing. Okay, we'll have to think on that. Uh, num keys. Again, 16, right? So we have num keys, and we're gonna just, for the sake of, I guess, neatness, have them like this. All right, we have that. Then we have the display, right? Which is again something that can be a single bit rather than a whole byte, but that's something else we can think because we only have monochrome information to display, right? So that's why. So this is screen width, right? This is screen width and height. That is going to be different. That's for the window itself. We're going to have uh, for the viewport, right? We're going to have, which is the display. We're going to have AT display, or rather, let me just type viewport height, right? So the height in this case is 32, right? And we have the viewport width, just 64, right? And then finally we have that as an array as well, and we'll just store it as a 1D array because why not? And that's going to be viewport height times viewport width. Oh, spelled width wrong. It's not good. Okay, viewport width. Yep. All right. And we need a comma after that. Oh, no, thank you. All right. Yeah, that should fix it. Structuring. All right. Cool. Aside from that, I think we're good for now. Sound delay timers. Yep. And then we have instructions. And as I mentioned, those will be like functions that we will define. But for now, we're gonna ignore them. Right. So now we have, yeah, standard chip8 instructions. So as I mentioned in the last stream, now what we're gonna do is focus on now that we have our structure in place, what we can focus on is tying in this display with the SCO2 display, right? And I'm gonna work on that probably either tonight or maybe tomorrow. But yeah, this was essentially initializing the structure. It's pretty straightforward, right? It's pretty small, right? Not really much that I added. Just rename this constants. Yeah, let me know if you guys have any feedback or anything like that. But thank you so much.